All right, welcome back to Everything Mathematics. And to wrap up this week, I thought it would be wise, again, as I said yesterday, to do some practice question to see the level of which, because you see, to see the level in which the various rules that we would have done so far can be applied. Because you see, sometimes when we look at the rule in isolation, which is what I would have been doing throughout the course of the week, sometimes when we get a question because let's say we're not familiar with how the rule could have been applied, sometimes we miss it. So let's look at the question. So at least that could hopefully develop a mental picture as to next time when you see something like that, how is it that you have to think about it? Or how is it that you could have go about solving it? So we have various levels of questions and all of them, I'm only writing it on this screen. In all of them, we have to find x. So yes, we're doing algebra, but with logarithms. We'll have to find x in all of them. And to be honest, I just went online and I just choose random questions. And I only choose those that the rules that we would have been doing for the last 3 days, well, since last week actually, will be applied. So first question is this. We have log 4 of 2x plus 7, and that's equal to 2. And again, we want to find x. We want to make x the subject. We want to know what is the value of x. And when we look at this like this, it's like, I wonder which rule can I use here? Can I use rule 1? Look at them adding 2 things inside here. Can I just separate it? Or should I use rule 2? Is there any subtraction sign? No. Or can I use rule 3? No. This here comes back to what we did last week, Friday, converting into index form and converting into log form. Right now, this is as an index, sorry, it is as a log. We need to write this as an index. And remember the concept, it's harder to see here, but that is what it comes down to. 4 is the base. So the base raised to this index would give me this. So as it is in the log form. All we need to do is write it in the index form and then see what magic could happen after that. So if we write this in the index form, guess what? We would have 2x plus 7 is actually equal to 4 squared. Or you could put it the other way around, because remember, what's inside here is basically the answer. So you could easily also say 4 squared is equal to 2x plus 7. And once we're able to see this, I think from here, everybody will say, I could solve this. So yes, this here is the easy part. And this is what we've been doing for the whole week. I've just been presenting to you the path to solving. I haven't been solving. But here we have what understanding the index form and the log form could help you to do. And I must admit, this is not one that you might see off the bat straight away. But it happens. And sometimes they tend to be difficult because we think sometimes so complicated that the simple things we miss. And this is one of the things that could happen very much often when you're dealing with logs. So here, of course, it's just a matter to home run now. 4 squared is 16. That's equal to 2x plus 7. And this is a simple game of making x a subject. So I send the 7 on this side. That will leave me with 16 minus 7 is equal to 2x. 16 minus 7, that looks like what? 9? Is it 9? Not sure. Oh, stupid is that said, I'm not sure. Of course it's 9. And 9 is equal to 2x. And if I divide both sides by 2, I will see that x is actually equal to 9 over 2. Or if you want, you could put 4.5. Up to you. 4.5 and I'm writing 4.25. Oh my goodness, whole week I'm doing this nonsense. 4.5. Good. So yes, this is how we would have go about finding x. And one of the things you could do, you could always prove your answer. You could always check it and ensure that what you found is what it actually is. So in essence, when we put in these two x, really and truly what we're looking for is 8. And that, not 8, 16. And that will equate close enough to 16 because 2 times this will give us 9, and 9 plus 7 will give us 16 because 4 raised to the x, 4 raised to the 2 is 16. I'm not sure if you understood what I said, so let me just demonstrate. In essence, we're saying that what's inside here is supposed to be equal to 16. And we could see that is true because if x is 9.5, let's leave it as 9.5, and we substitute in here. So we have 2x plus 7. X is 9/2. So we have 2 into 9/2 plus, 9/2 plus 7. 2 cancel 2, leaving you with 9 plus 7. And that's equal to 16. So 16 is equal to that. Good. And that's true because 4 squared is equal to 16. So we know that's true. Anyway, moving on. No sticking. Next one. So what we have next? Here we have log x. So they give us log x of 64 is equal to 2. And again, this one is an even simpler one because just now here we had an expression here so that we had to see. But this one is a little easier to see because we only have a single entity, a single number. And again, the rule remains the same. X raised to this supposed to give us this. So this is the same as x squared is equal to 64. And this could easily be solved. Well, we all know that x squared is the same as x times x. And in essence, we're asking what number can we multiply by itself to give us 64? And here we could easily get 8. So 8 squared is equal to 64. 60x, 0x, 6x, 64. Yes, is equal to 64. Sorry about that. Is equal to 64. Therefore, we could say that x is equal to 8. X is equal to 8. Yes, that's what it actually is. Another way to go about it, because again, this might look like a little guessing. It's like, okay, what if you did not know the number that could give you 8, you know? The other way to really go about doing this, and this I would say maybe solving it mathematically, that is, you just apply one of the laws of indices. So one of the laws of indices says that so long as you could get the bases to be the same, then whatever the powers are will be the same. But we don't know the bases here, but we could know the powers because we know 64 is actually the same as 8 squared. So notice, because the bases are the same, we could assume that the indices are the same, 2 and 2. We could also assume that the bases would be the same. So that's actually one of the rules. So, but that's a law of indices. One of the laws of indices. It dictates that once the bases are the same, you could equate the powers. But here I'm doing it kind of like the reverse. Because the powers are the same, I'm presuming that the bases are the same. It doesn't always have to be the case though, but yes, in this case, we know it is because this one we could easily see that. There is no other number you could square to get 64 besides 8. Try all you may. Good. Let's try another one. I think I have 2 more remaining. The others will be a little more challenging or a little more taken. This rule we haven't done, but that's why I chose this one so that at least it could come out. Because it's one of the things, and well, it's not really a rule. It's more like a concept or a fact that you just have to know. I can't say it's a rule. What the rule would say. Good. So in a case like this, of course, first thing you see the logs, and again, probably thinking, okay, 7 raised to all this is equal to this. So yeah, you could do that, but then again, you just end up with that rule where you end up with 2x minus 7. Right, so the concept here goes as follows. Once you have 2 logs on the both sides, you could easily eliminate the logs and just work with whatever you were logging, so long as the logs are of the same base. So in this case, notice that we have the log of 7, we have log 7 on both sides. Therefore, it's okay to just cancel the logs. And that will simply leave us with 8x minus 7 equal to 2x plus 30. And from here is a simple game again of just finding x. So here I send my x here and I would send that 7 over there. The x is positive here. When it comes over here, it will be negative. So that will leave me with 8x minus 6. Oh, wow, what a jump, what a corner jump there. 8x minus 2x, just change my writing, 2x. And that's equal to, on this side here, I would have 7 plus 13. Good. And when I solve on this side, I will get 6x. And when I equate on the other side, I will get 20. And I simply divide here by 6, and I divide here by 6. Of course, 6 cancels 6, leaving the x alone. And on this side, we could break down, or we could break down before we put it as an improper fraction, a mixed fraction. So we could use 2. 2 could go into 6 3 times. 2 could go here 10 times. And now we could say that's the same as 3 and 1 over 10. I trust I did that right. But again, it's a concept I wanted to get, not necessarily the example, because the example could always change. Let me just write that one here properly. Yeah, so that's basically how we would have solved this one. And what rule did we use here? No rule really. Here we just have to know the fact that once we have two same logs on both sides, we could just cancel them. Or if it serves you better to comprehend, you could simply see this as you're canceling log. So it's like you divide this side by log 7, and it's like you get rid of log. So you divide this log by log 7 cancel log 7, and what you do on one side, you do on the other side. So log 7 would have canceled log 7 too. I don't know if that approach would also help you to see it in a whole different light or even better. So I could cancel log 7 on both sides because both sides have log 7. Look at it that way. And mind you, that would only work if the logs were the same. Good. And here we have our very last one. This one, when I look at it, it was 6 marks, I think I saw it was. It was a 6 marks question. I will need space for this. I'm not sure if I could do all on one side. This one ended up very interesting. So we have log 2 of 11 minus 6x, and that's equal to 2 log 2 of x minus 1, x minus 1 plus 3. And mind you, of course, well, this is the last question. I should have said that earlier, but of course, we could pause it and see how you think you have to figure it out. Should have done that for each question before I started solving. And then, yes, we see how we could have been solved. So here, I mean, we have a lot going on here. We have a lot taking place here. And the first thing you go ask yourself is like, well, how do I do this? But I'll just tell you the gist of it, and then I'll show you, I'll just solve it. So when you get something like this, first of all, you want to put your logs together. See if you could find a way to get rid of the logs. And once that is happened, or once you achieve that, then you could easily simplify, right? So let's see what happens. So let me bring my logs together. So if I take 2 log 2 into x minus 1 on the other side, I would end up with this. Log 2 of 11 minus 6x. This is positive, so when I bring it on the other side, it will be minus 2 log 2 of x minus 1, and that's equal to 3. So I'll send this on the other side of the equal sign. Therefore, the 3 stayed alone on that side, okay? And that's okay. Leave the 3 alone, don't worry. The 3 will get company just now. Right. After this now, notice I have a subtraction sign here. So I could apply rule 2, I think. That's the one where you have to make it into a quotient, into a fraction. But before that, I will apply rule 3 because there's a 2 here, but I want this 2 to come back to where it initially was. So before I do that, I will bring back the 2. So I have log 2 of 11 minus 6x minus log 2 of x minus 1 squared. That's equal to 3. Good? Hope you understand what happened here. And now I could apply rule 2 because we are finding the difference of 2 log entities and they have the same base. So this is the same as, really and truly, log 2. Remember, this one becomes the denominator. Let me put it as a fraction. So we have 11 minus 6x all divided by x minus 1 all squared. And that is still equal to 3. Good. And at this point, you might start hurting your head now. It's like, okay, what next? Remember, it's x we're trying to find. We want to know x. I don't know about you, but from the minute I saw this here, I know that I will end up with a quadratic equation. The question is where and when. But let's see how it goes. So from here now, and I think this would have been the hardest thing in this question, here now you would have to be able to identify again that we have a log which can be written in an index form. So this would have gone something like this. 2 raised to the 3 should give you back this here. Yes, I know this one is what I would call a proper disguise. But yes, that's what it is. As a result, when you do that now, let me change. No, let me see if I could set a division line. I want a line right here. Oh, no, I don't want to move. I want to draw a line. So let me put a line here. So I could work on the other side. Good. So when I do that, I will end up with, let's say 2. Should I put it on this side? Now, let me leave it on the other side. So on this side, I will still have 11 minus 6x all over x minus 1 all squared. And that's now equal to 2 cubed. So remember, the base raised to the index is equal to the answer that we have here. So that's that there. And 2 cubed is the same as 8. And I'm just replacing it right here in interest of space. Right, from here now, remember we're finding x, so the algebra again starts. So we have 11 minus 6x, and I could easily cross multiply the top. So that will be 8 cross multiply the denominator here, I mean, into x minus 1 all squared. And please don't make the mistake of multiplying this 8 by this x plus 1 right here. Otherwise, you'll get the wrong answer. You have to expand first. So if you expand, let's see, we will end up with 11 minus 6x equal to 8 still on the outside, and on the inside, I will have what? X squared minus 2x plus 1. Yep, that's when we expand the x minus 1. In other words, it's x minus 1. In essence, we have x minus 1 multiplied by x minus 1. At this level, that's supposed to be a simple expansion, so I would not go through that. Or should I? I use this shortcut. So my shortcut here was I square the first one, I square the second one. So when I square the first one, I get x squared. When I square the second one, I get just 1. Negative 1 times negative 1 is 1. And for the middle, I multiply the last by the first, or the first by the last, and you double it. So I multiply minus 1 by x, you get minus x, and you double it, so you get minus 2x. That's the approach I took. So either way, whichever one you want, you could use at your convenience. So this is the same as 11 minus 6x equal to, and now I could distribute my 8. So this will be 8x squared minus 16x plus 8. So I basically distributed my 8 into the fraction or into the quadratic. And here I just try to find a quadratic equation. And let me see if I could kill 2 birds with 1 stone. I will send this negative 6 on the other side, it will be positive. So that means negative 16x will become negative 10x, because this 6x will be positive, and a negative will be negative, but you subtract. So yeah, that's that. The 8x will remain 8x. Nobody will be interfering with Mr. 8x squared. So that stays so. And this 8 will be subtracted from this 11, and that should give us negative 3. Right? When this 11 goes on the other side, it will become negative. So it will be 8 minus 11, and that's negative 3. Take away the smaller from the larger number, but you keep the sign of the larger number. And all that's equal to 0. And from here, we have a simple quadratic equation. We find AC. We could use the AC method here. If I use the AC method here, I will end up with 0 is equal to, the AC method here, I get AC, which is 24. And 2 factors of 24 that could add, subtract to give me 10 is 6 and 4. 6 and 4 is 24. And 6 minus 4 is this. So I will have here 8x squared minus 6x minus 4x minus 3. At this level, yes, we have to be experts of factorization, and this is what I'm doing here. I'm factorizing. I have videos up on factorizing, so if you're not sure to factorize, you could go ahead and do that, find out. And from here now, matter of fact, hold on, let me erase this. Let me take this to the next page, because I know I wouldn't have enough space here. So let me memorize this. You have 8x squared minus 10x minus 3. Good. So taking it to the other page. So we have 8x squared minus 10x minus 3. That's equal to 0. Notice on the previous page, right? Whether I have the 0 first or I have it after, it doesn't matter, so long as I did not change the equation. Right. And from here, from here, I was showing us that we have 8x squared minus 6x minus 4x minus 3 is equal to 0. We could group here and we could group here. In this first one, the common factor will have 2x. And we break down here, 2 could go into 8 4 times, and x cancels x squared, x times, minus 3 on this side here. And on this side over here, let's leave it as 1. So that would leave us with 4x minus 3, which is what we want, equal to 0. Good? Goody, goody, hunky dory. And from here, of course, the next thing that we could do is solve for x. So here we would have 2x minus 1. And over here, we will have 4x minus 3. Sorry, 4x minus 2. No, 4x minus 3. Good, equal to 0. And if we go to solve for each one, we will see in one of them, x will be equal, in this one here, x will be equal to this trig on the other side, that will be 3/4. And on this side here, x will be equal to 1/2. Something wrong. Because both of these values positive and we're dealing with a log. So more than likely one of them has to be negative so that we could cancel out. So hold on, let's see where I went wrong. Something wrong. Oh, I think I see it. Yes, right here, right here. This is a mistake. Right here. -1 times this would not give me back the top. We will get a positive. Oh my goodness, wow. So that means we have the wrong factor. So when we found AC, oh, this is interesting. When I found AC, I used 24. AC, that was 3 times 8. And I used the factor 6 and 4. But seemingly this cannot work. Therefore, there is another factor. Yes, 12 and 2. 12 and 2 is also 24, and 12 and 2 could give us 10. Oh my goodness. I'm pretty sure it's 12 and 2. So let me do this again. So then we have 8x squared, wow, that is maths. 8x squared minus 10x minus 3 is equal to 0. So look at this. We started with logs, this is a log problem, This is a logarithm problem. But the problem here we have, is with the factorization part of it. Yes, but we need to know our rules. So this is the same now as, let's see, let me try this one and see if it works. 8x squared minus 12x, yes, plus 2x minus 3 equals 0. Minus 12x plus 2x will give me back my 10x here. So I could accept that so far. Let's see what happens here next. When we group here and we group here, in this one again, well, we will have now 4. So we have 4x here now. That leaving us with 2x minus 3. Looks familiar. And over here now we have 1 as a factor, but we don't must put that 1. So that will leave us as 2x minus 3. Okay, good. And that's equal to 0. So if I find my two values now, so here we'll have two factors. We firstly have 4x plus 1, and then we have 2x minus 3. I wonder how long is this video? Equal to 0. Because we've been doing a lot of questions. I find this one took longer than I expected. Right, that's the sad thing of trying to work out questions live and not trying them beforehand. Anyway, I prefer it this way. It's more spontaneous for me. Right, so when I solve here now, inside of this one, I will end up with x being equal to -1/4. And inside of this one, I will end up with x is equal to 3/2. Very good. And why I noticed something was wrong again, usually when you do logs and you get a quadratic equation, usually the two values for the x, which are the critical values, usually both of them don't work. Usually it's either or. And that's why I know that, that's why I realized something went wrong here. As a result, I did it over. Notice now I have a positive value and a negative value. When it comes to logarithm, x cannot be negative. In fact, x must always be greater than 0 because you just cannot have the log of a negative value, including 0. You cannot find a log of 0. A log of 0 will be undefined. And any log that is negative or less than 0 would not be able to, it's not possible to calculate. It's just not feasible, not practical, not possible. And that just comes with understanding log. Maybe I could look at a proof later down the line to justify why logs must be a positive value. So yes, in this case, even though we found two values for x, you now need to know that although you found two values, the correct value is this one, where x is equal to 3 over 2, which is 1.5, because it's positive, or if you want to put it the other way around, it is greater than 0. Oh, that was some proof. Oh, that was some question. That question was long, man. This video could have been done with just this question. So we started here with this long thing here. We applied the log where we could have applied the log, and then we went to an algebra question that took us to factorization. Yep, we end up factorizing. So yes, this will be the end of today's video on a Friday, long one. I don't like them long ones on Friday, but so be it. It may not be a Friday, you'll be looking at this. So until next time, of course, you take care. Subscribe if you haven't as yet. If you have any question on this, of course, feel free to leave it in the comment section or find a way to contact me. I'll be glad to respond. Enjoy your weekend and you take care.